So, is your parent rational? The equation f of x equals 1 over x is called the rational parent function. Why is it called rational? Because it's a fraction, right? That's the first thing. What else do we call a fraction that's in this word? A ratio, right? It's a ratio. Whoops, if I could spell ratio correctly. Or fraction. Jiminy Christmas, I can't spell it all today. It's a ratio or fraction. Okay? So why is it called the parent? Any ideas? Why is any function we've dealt with called a parent? It's the simplest. Oops. I don't even know how to spell simplest. What the heck is wrong with me today? Somebody spell simplest for me. L-E-S-T, simplest. Forgive me, guys. I'm sorry. It's the simplest form, and all other rational functions start here. Okay? It's the simplest form, and all other rational functions start here. So are we clear why it's called a rational parent function? Okay. So let's graph this rational parent function. Let's get a table and let's plot the points. Okay? There's some of the things we need to talk about. I need to make sure you know about. So let's start a new document in our calculator. And let's make it a graph. Have we talked about control divide yet? Have we talked about control divide? Look what happens when I press control divide. It gives me a fraction. I don't have to figure out parentheses or anything like that, okay? So 1 over x is what I want. And I need my table, so I need control T. So I'm having a problem. Are you having the same problem as I am? Let's copy what we have first of all. That's negative 0.1. 5 is negative 0.2. Negative 2 is negative 0.5. Negative 1 is negative 1. But here's what my problem is. My table on my calculator goes from negative 1 to 0. Does yours do that too? But I need these two values, don't I? So let's put in what we know first. Let's fill in what we know in this table over here first. Okay? That's undefined. I can go to 1 and 2 and 5 and 10. Yeah. Okay? So what I need to make sure that you understand is how to change what I see on my table in my calculator. How do I actually need these numbers to count so that I can get these two and these two? 0.25, right? Okay, so what we want to do is hit menu. And when we hit menu, we have two choices, actions or table. Well, we're needing to mess with our table. And look at number 5, edit table settings. Let's choose number 5. If we're trying to find this value right here, we want our table to start somewhere around there. So let's make it start at negative 1. And how did you say you want my table to change? 0.25. Nope, not right there. Right there. So now tab until OK is highlighted. and hit enter. Oh, look. So what is negative 0.5? Negative 2. And what is negative 0.25? And what is 0.25? Oh, look. Let me see if I can make it do that again. Hold on. Dang it. Okay. Do you see how you can't hardly see anything in this column now? It's just because the value in the column, it fits in that area. But if something happens and you go to the next one and you can't see everything that's there, this is like a spreadsheet document where if the cell is highlighted, somewhere it tells you what's in that cell. Okay? So like you can't see this whole word right here, but if you highlight that cell and look right here, it tells you what it says, everything that it says. Does that make sense? Okay? So 0.25 is 4 and 0.5 is 2. Okay so far? Let's plot these points on this graph. Can I plot the first one? Why not? My graph isn't big enough, is it? Okay, so the next one. Negative 5, negative 0.2. How do I graph negative 0.2? A little bit further, right? Negative 2, negative 0.5, so halfway down. Negative 1, negative 1. Halfway down to 2. A fourth of the way down to 4. 0 is undefined. What's happening at 0? Do you remember? Okay, we'll get to it in a minute maybe. 0.25 up to 4. 0.5 to 2. 1, 1. 2. Halfway up. 5. A little bit of way up. Now, can I connect these? How do you know? How do you know I can connect them? Maybe. How do you know it's continuous? What did we put into the calculator? Oh, there's a function. That's how we can tell we can connect it, okay? Because there's a function that's given to us, okay? So something like that, yes? This graph has both a horizontal asymptote and a vertical asymptote. Asymptote. Okay, are we good? Okay, what's an asymptote? What is it? It's nothing, right? Nothing can exist where an asymptote is. But there's actually a mathematical definition. We've talked about an asymptote being nothing because nothing can live there. Okay? But the mathematical definition of an asymptote is a line that a graph approaches as x or y values extremely large or small. That's the actual mathematical definition, or something close to it. Okay, this is what we need for our stuff right now. Okay. So where are the asymptotes on this graph? Can you see one right here? What's the equation of that line that I just drew? In this case, it's the y-axis, right? And the equation of the y-axis is x equals 0 because that is the axis that it is crossing and where it's crossing that axis. Okay? Do you see any more asymptotes? Here? Like that? And that's y equals 0, right? Because it's crossing the y-axis at 0. Why do we draw asymptotes as dotted lines? Because they're not really there, right? Okay. So let's do some how does this affect the domain and range? Remember, for domain, we say how far left does it go and how far right does it go. How far left does this function go? How far right does it go? Forever and forever, right? But what happens at 0? Nothing can happen at 0, right? So for our domain, we talk about our domain being all real numbers. What does that mean? Very good. Okay? All real numbers except for 0. It can be anything except for 0. So what about the range? If domain we're talking about left and right, what are we talking about in range? Down and up, right? So how far down does this go? And how far up does it go? Forever and forever. So what happens at 0? Nothing. So what's this range going to look like? So all real numbers, but y is not equal to 0. Very good. Okay. So let's look at these 3 samples at the bottom. Do you see any asymptotes in the first one? Horizontal or vertical? Which one do you see first? Horizontal? Okay. Where do you see a horizontal asymptote here? So like right here. And the equation of that is y equals 0. I'll try to write that darker so you can actually see it. Is that better? Does anybody else see any other asymptotes? So you see a vertical asymptote? Here? X equals 2. Okay so far? Is there another vertical asymptote? No, there's no more. Okay? Because this line is here and it keeps on going, and this line is here and it keeps on going. There's not a vertical place where the graph comes to and kind of just like stops. Do I have the wrong color? I do have 2. I have 1 of each. So what about problem number 2? Let's talk about vertical asymptotes first on this problem. Where is it? If we're talking about vertical, we're talking about up and down. Where is it? X equals -1. Okay. What about horizontal? Do you see one? Good. Y equals 2. And the last one? So x equals 3, that's the one you see first? Good. So right there. So, normally, when we start talking about the graphs, what's the next thing we talk about as far as what we do with the graphs? How about transformations, right? And in a quadratic, what did we move? Yeah, we moved the whole function, but what did we focus on? The vertex, right? When we moved a square root function around, what did we focus on? Like the end of it, right? The beginning of it. When we moved an absolute value around, what did we move? The vertex again, right? Okay. What do you think we're going to focus on when we do rational functions? What are we going to move? We're going to move where the horizontal and vertical asymptotes cross. That's going to be our main point of motion. Okay? So look at the other worksheet I gave you, please. Guess what it's called? Oh my goodness, transformations. I hope that when we get done with school this year that transformations is your favorite thing to do because you're the best at it. Okay? Being able to know transformationally, being able to shift functions around transformationally is such an important way. Like that's how we teach. That's the way we approach algebra. Okay? That's the way a lot of schools around the state and the United States, for that matter, approach algebra, from a transformation approach. Okay? So, have we done anything like this before where we have A, H, and K? So this isn't new stuff, is it? It's just a review. The only difference is we're in a different function this time. You know how we always talk about inside or outside of the function? Things like that? What are we talking about this time? Inside or outside of the fraction. Okay? There's no parentheses. There's no square root sign, anything like that. We're talking about inside or outside of the fraction itself. Okay? So what does a change in our a value cause our function to do? A is not going to cause a shift. That's a good guess, though. It's going to cause a stretch and a compression, or a compression. Yikes. Or one more. Use your context clues. A reflection. Good. What causes a stretch? What about A causes a stretch? When A is greater than 1. Good. What causes a compression? When A is less than 1 and greater than 0. Very good. So what causes a reflection? When it's negative, so if A is less than 0, right? Now if you want to write when A is negative, that's fine with me. It means the same thing. Okay? Let's look at H and K. So, okay, first of all, as we're going through some of this stuff, is it ringing a bell at all? Yes? Okay, good. That makes me feel better. So H and K. One is a horizontal something, one's a vertical something. Something, what something? Horizontal what? Yes. And what's the most important part of that word? The F, right? We got to remember our F's. Okay? Please remember to write the F when we spell this word. Okay? When is it going to move right? When is this function going to move to the right? It's going to move to the right when it looks something like this, 1 over x minus 3. You remember that? If it's inside, it moves opposite of what we think it would do. So when is it going to move left? 1 over x plus 3. Good. So K causes a vertical shift. It's going to move up when K is positive. Excellent. I think you are remembering more than you thought you would, yes? When is it going to move down? K is negative. So these bottom three examples down here, we need to write the function rule. Okay? Write the function rule. So here's how we're going to start. We're going to get ourselves a line. Straight if you can, unlike mine. Okay? So first of all, we have to decide, is there a multiplier? Is there a stretch or compression in this problem? Well, think about our parent function from earlier. What does it look like where these two cross? How do I get to that first point on both sides? 1 and 1, right? 1 and 1, 1 and 1. Is that what's happening here from the intersection point? So is there a multiplier? Nope, it's just a 1. Is there a horizontal shift in this function? Does it move left or right any? Which direction? To the right how many? 3. So what goes below? X minus 3. Why is it minus 3? Because it moves to the right. It's opposite of what we think. Okay? Is there a vertical shift in this problem? Then we're done, guys. So what about problem number 2? Is there a multiplier? No. Is there a horizontal shift? No. So what goes down here? X. And is there a vertical shift? How much? So what goes where? Plus 1. Done. Last one. Is there a multiplier? No, so what goes here? 1. Is there a horizontal shift? Where? To the left 1, so this is going to be x plus 1. Good. Is there a vertical shift? Where? Up 2, so plus 2. Done. Questions? So the back is your homework. Let me make sure you understand what to do. Okay? There's a couple different ways to do it. I would recommend you do it the smart way. Okay? Not the guessing way, but the smart way. Let's talk about can't. Okay? Do you see that this is the graph for can't? And do you see that this is the graph for what? Yes or no? Okay. So if we're talking about the can't graph, is this, or does this have a multiplier? Yes, it does. How are we going to figure out the multiplier? If I go over 1, how many do I go up? Over 1, up 4. Guess what my multiplier is? 4. Is there a horizontal shift? No. Is there a vertical shift? No. That's the equation for can't. Let me go find it down here. Oh, look, there it is. You see what to do? Look at this graph, figure out the equation, write the equation, then go find it down here. Don't just look at the words and trying to figure out what they say. I don't care what the words say. I care about the math. Deal? Any questions? Okay. Have a good day.